Hopefully you're still on Learning Workbook page 136. Let's continue with a final example of finding domain. Suppose that the functions f and g are defined as follows. F of x is equal to the principal square root of the difference 5x minus 2. G of x is equal to x squared plus 1. Find f plus g and f dot g. Then give their domains using interval notation. All right, and then when we're done with that, there's one more final question which says find all values that are not in the domain of g over f. We'll get to that in a moment. All right, let's go ahead and begin with this. F plus g, so that's the same thing as f plus g of x, because both f and g are functions of x. This means f of x, g of x, added together. Replacing f of x with what it equals in the problem, we get the principal square root of the difference 5x minus 2. Replacing g of x with what it equals in the problem, we have x squared plus 1. Neither one of these things has a multiplier, a subtractor, or an exponent, so we don't need parentheses for either one. We can just put a plus sign in between them. All right, so this is the moment when we no longer have any names of functions, right? The names of our functions were f and g. This is the first line where those do not appear anywhere in our problem. So this is where we stop and determine our domain. Okay, so let's go ahead and determine our domain for this particular function. We go through the 4 steps. Step 1, start with all real numbers. Step 2, even radicands greater than or equal to 0. Our even radicand is 5x minus 2. So that has to be greater than or equal to 0. We get 5x is greater than or equal to 2, and divide by 5 on both sides. X is greater than or equal to 2/5. As an interval, that would be 2/5, comma, infinity. Step 3, logarithms, we have none. Step 4, denominators, we have none. So this right here is our domain. This is the interval. And this right here cannot be simplified, so therefore it is our final answer for find f plus g. All right, let's move on to find f dot g. So that's the same thing as f dot g of x, which is equal to f of x times g of x, which is equal to the principal square root of 5x subtract 2. Times x squared plus 1. Now, in this case, we do have a multiplier, so we need parentheses around the x squared plus 1. No parentheses are needed around the square root because it is itself a grouping symbol. Okay, this is the part of the problem where we no longer have names. All the names are gone, so this is the moment where we are going to stop and determine our domain. Okay, so you're going to find that this is going to be really similar, right? We start with all real numbers. There's an even radicand, so 5x minus 2 has to be greater than or equal to 0. When we solve that, we're going to get the same result as before, which is the interval 2/5, comma, infinity. There are no logs and there are no denominators, so same domain. Now when it comes to simplifying this, the only thing that I would recommend doing is moving the radical to the end. So then we would have the x squared plus 1 times the square root of 5x minus 2, and that would be our final answer. All right, so there we go. We found f plus g, f dot g, and the domains of both in interval notation. So the only thing left to do for this problem is to find all values that are not in the domain of G over F. All right, so let's see if we can do that right now. All right, so find all values that are not in the domain of G over F. All right, so first let's go ahead and create G over F. G over F is the same thing as G over F of X, which is the same thing as G of X over F of X. All right, let's go ahead and create that fraction. So G of X is X squared plus 1. F of X is the principal square root of the difference 5x subtract 2. Okay, so this problem is worded very specifically. Find all values that are not in the domain of this. Okay, well, if we think about that, one way to figure out what's not in the domain is to figure out what is in the domain and then just say not those values. Another way to answer this is to identify what are the things that we are not allowed to do in this problem and then put them together. The wording on this is not ideal, in my opinion. It seems unnecessary to ask what are the elements that are not in the domain. But we'll answer the question the way it was asked. All right, so here we go. So let's go through and find out what is in the domain first. We're going to go through 4 steps. All right, step 1, we're going to start with all real numbers. Step 2, any even radicands, the radicands have to be greater than or equal to 0. So in this case, we do have an even radicand. It's 5x minus 2, and 5x minus 2 has to be greater than or equal to 0. We've solved this several times already in this problem. This is the interval 2/5, comma, infinity. Step 3, logs. There are none in this problem. Step 4, denominator. We do have a denominator here, and this is what makes this problem so interesting. The denominator is the square root of 5x subtract 2. So the square root of 5x subtract 2 is not allowed to be 0. So let's be thoughtful for a moment here. There is only one number in the world whose square root is 0. If I were to ask you, what do you have to put underneath this square root so that it gives you the result 0, you would say 0. 0 is the only thing you can take the square root of and get the value 0. So let's think about what it says in this particular problem. What it says in this particular problem is this thing under here, when you take the square root, is not allowed to give you 0. So that means that anything underneath is not allowed to be 0. So we get 5x minus 2 is not allowed to be 0, and therefore x is not allowed to be 2/5. Okay, so now we just have to put these things together. So this is what we had at the end of step 2. And now we're going to remove 2/5 from this collection of numbers. Well, right now 2/5 is being included. We now want to exclude 2/5. And so this gives us the following result. Okay, these are the numbers that are in the domain. But the question that they asked us is to find all values that are not in the domain. Okay, well, let's think about what we've got going on here. If I were to graph these, it would look like this. At 2/5, I could have parenthesis, and shading all the way to positive infinity. Those are the numbers that are in the domain. So which numbers are not in the domain? Well, that would be everything else. Everything else from negative infinity all the way to 2/5. So my final answer to this question is parentheses, negative infinity, comma, 2/5 brackets. I'd like to again emphasize, these are the numbers that are in the domain. These are the numbers that are not in the domain. And that is the end of this problem.